Okay, so y equals x squared is not 1 to 1. 1 to 1. Why is that, Sarah Chung?
Because you plug in negative 2, you'll get 4.
Okay.
So you have your outputs on the same.
Right. The y cannot, even though that's a function, it's totally passes the vertical line test, whatever else test. Okay. So a function is not always 1 to 1, but a 1 to 1 function is always a function. So, 1 to 1 is just a little bit more specific than any function. Okay. So two different outputs correspond to the two different inputs correspond to the same output. Just like this example that she gave me. Okay. We put in a 2, we get a 4. We put in a negative 2, we get a 4. That's the output. Same output, different inputs. Okay. All right. Let's look at these functions. We've got populations. Notice who made the list. South Dakota. Get that puny little population. Anyway, so we got Indiana has a population, Washington, South Dakota, North Carolina, and Tennessee. Is that 1 to 1? Yes. Each input has one output. Okay. What about this one? No. Because that's right. So if you were looking at Katie drives a Honda, that's your ordered pair, and Carrie drives a Honda. Okay? All right. Okay. What about part C? Don't say it out loud. Don't say it out loud. Okay. Yes or no, Riley? Perfect child, Riley Warren. Yes, it's 1 to 1. And what are you looking at? Each y has a different x. Each x has a different y, vice versa. Okay. All right, very good. Now this is called, you remember what this is called when you match them up like that? It's called a mapping. Okay. It's real easy to see, especially in terms of this, that, you don't have a 1 to 1. Everyone has its own. If you did that over here, your domain would be here. So 1, negative 8, and 3. Your range would be here, and they're exactly matched up 1 to 1. That's what that means. Okay? All right. Horizontal line test. Every horizontal line intersects the graph of a function in at most one point, and the function is 1 to 1. Okay? This is clearly not 1 to 1, right? Because I can draw 1,000. I hit it once, I hit it twice. And those are the two, this is just an example, but let's say it's 1, 2, and negative 3, 2. Different x, same y. Okay? All you do is find one place where that happens. I could find 1,000 places that that's going to happen with my vertical line. So the horizontal line. So the horizontal line is a 1 to 1. The vertical line tests for what? Functions in general, right? So this is a function, just not a 1 to 1 function. Okay? All right. Okay. Let's talk about inverse functions again. Okay. Now, inverse functions are in every chapter from here on out. You can see we're doing inverse functions over here in calculus. Okay. So if f is a 1 to 1 function, then this is kind of messed up, isn't it? They're all got misplaced. What is it supposed to say? To each x in the domain of f, there's exactly one y in the range. Its parents just kind of shut together. And to each y in the range, there's exactly one x in the domain. Okay, so it says that. Just make sure you know what it says. One y, one x. Okay, So 1 to 1, just like we said on the other pages. Okay. The correspondence from the range back to the domain is the inverse function. Okay. Y'all seen this notation before? Okay. How would you say that notation? Inverse of f, right. It is not f to the negative 1 power. That is something totally different. Okay? So this is inverse of f, or just inverse f, however you want to say that. Okay? All right. So, inverses. You're swapping out your y's and your x. All right. What is the inverse function? Okay. So tell me what the inverse function of this same function is. Richard. Okay.
That's the inverse.
Well, not yet. She's starting on it.
And then I keep repeating.
Okay.
6,068,996 Washington. 761,063 South Dakota.
Okay.
8,320,146 North Carolina. 5,797,289 Tennessee.
Okay. So those are the ordered pairs. That whole thing is the inverse function. Okay. So tell me how you find the inverse function. Okay. Change the x's and the y's. That's what this says. Okay. All right. What about this function? What's the inverse function? I'll call this f. So this would be called f inverse. What are the ordered pairs now? Catherine. Okay. Now, we have gone away from the individual functions, you know, like listing the ordered pairs. We haven't done that for years, right? Right? All right. So, how do we, hold on, let's just think about this. How do you think we change this, which is a function, to its inverse? What do you want to do? Natalie?
You swap the x and the y. So if x equals y plus 3.
Okay.
And then you solve for y.
Okay.
So subtract x over, or subtract 3 over this.
Okay. And so the inverse is?
X minus 3.
Okay. So those are inverses. So swap them out, and you solve for the y. Okay? Now, is this line? This is the line, right? Is this 1 to 1?
Yes.
Yes. For every 1, 2, 3. For every x, you have a y. For every x, you have a y. Yes. No, not all functions are one to one.
Linear. Not like the,
Probably. If you're odd, but it's a little bit, I mean, we gotta look at different things other than just the function. Do what? You want, because you take the cube root to do the inverse, and there's only one cube root. Unlike a square root, you have 2, right? Okay. But yeah, we are going to look into all that. Okay, so when two functions are inverses of each other, these statements are true. What do you call this again that we did yesterday, last class? Composite function. If you take the composite function, if f and g are inverses of each other, f of g and g of f are x. Okay, or look at this. It's the same thing except we're calling it f and inverse of f. And you have to do it both directions. Okay? So I got two functions here. I'm telling you that they are inverses. And you are going to verify that by doing this. Okay? So here we go. I'm going to first do f of g. Okay? Then I'm going to do g of f. And what should I get for both answers? X. Okay. Now that's the verification process. Okay. So that's the reason we did composition functions last class, so we would know how to do this. All right. So how do we start this, Sabrina? Okay, so she plugged in her g of x. Okay. And then where does that g of x go inside? Okay, so what does that look like? I'm putting it in the, okay, so x minus 3 over 2. I'm verifying. I can't just like, oh yeah, that equals it.
2x minus 3 over 2. There's 2 and then in front of
Okay, sorry. 2x minus 3. Don't get ahead of yourself. Okay. You're verifying. You don't just get to go like, okay, x. No, you got to show the steps. Okay. So it's showing things you need to. All right, here we go. What should we simplify first? The 2's. All right. So what does that give me, Renee? Which equals, okay, that's what we were supposed to know, okay? So be careful, show the steps, otherwise you're really not verifying. You're just saying, yeah, I know that's supposed to be true, so I'm just going to say, yeah, it's X, okay? That's what showing means. All right, start me off here, Ainsley.
Okay, so it's 2x plus 3.
Okay, first the G of
2x plus 3.
okay.
Is equal to 2x. 3 minus 3 all over 2.
Okay, very good.
So then that is, you can cancel your 3, so 2x over 2. And then that's what
All right. Okay, so you've just verified. You have to do both ways and show it step by step. Okay? So you've just verified that. You're going to do that with every kind of functions you can imagine. Okay? It gets a little bit more intense when the functions are not linear, but I'm sure you can handle it. Okay, let's try graphing. All right. Let me just do it on the calculator. If you want to get decimals out and put them on the same graph, that would be fine. Let's see, and that way you can just slide it on over. Guess I don't have my calculator open here yet. Again. All right. Okay, so we're going to put both those graphs on the y equals. Figure out what you got. What was it? 2x plus 3. Can't see it up there. And 2x plus 3. And x minus 3 over 2. Okay. Graph. And they look like that. All right. What do you notice about the graph of the function and its inverse? You may have already known this, but What do you notice? So what line are we talking about? Okay, so what is the, okay, that's what I was looking for. So I'm gonna put that in here. What color would you like that to be? Green? Let's go for green. Magenta. All right, y equals x. Yes. Now, if you look at this pink line here, the pink line is the function y equals x. The blue function is y equals 2x plus 3. And this red one is y equals x minus 3 all over 2. Okay, if you look, it is exactly what Sarah said, a reflection over that line. Okay? Reflection over the line y equals x. And it's always going to be that. Sometimes it's not as obvious to see, but it's always going to be that if it's the right inverse. Okay? What point is this? What is that intersection point? How would you describe that? Remember how you find the inverse? You switch around the x's and the y's. I know, in general, what is that going to be, though? Maybe that will give you a hint. She says it's -3. -3?
Yeah.
Okay? Yes. Yes, that's where x and y are going to equal. Because remember, the other ones are flipped. So 2, -1 is -1, 2 on the blue. On the red, we have 3, 0. We should have 0, 3 on the blue. Okay? Just as something to think about. Okay.
So it's where they cross is where x and y.
Yes. Yes, yes. Okay, we already talked about this. So let's write it down for sure. Interchange the x's and the y's. And what was the last step? Solve for y. Okay, you got to do whatever you got to do to solve for y. Okay? Sometimes it's squaring the equation, sometimes it's cubing, sometimes it's cube rooting, whatever you got to do. Okay, but that's, basically two things. All right, let's try one. Let's do, give me a nonlinear equation. Sarah, Tom. Nonlinear, non-quadratic, nonlinear. Okay? Okay, be careful, we can't get too complex because we don't, how about just +2? Because we don't really have the skills to go crazy. No, it's not your fault. I'm just saying, we can't even solve that. Okay, think about, how do you solve that for y? How do you separate the y? You don't know how to do that. So that's why we're just going to leave this at 2. Okay. So switch them up. What do we have, Sophie? X equals y cubed plus 2. Okay. And we need to solve for y. So what would that entail? Libby, do one thing for me. Okay. And what would be the last thing you'd have to do?
You would
The cube roots, or as Ruby would call it, root 3. Is that what she said?
Yeah.
She says cube root. Okay, like we say radical, so it makes sense. Okay, now are these 1-to-1? We kind of talked about cubes and cube roots. They're both 1-to-1, right? Okay. What about, give me a quadratic, 7. Okay. All right. All right, now, What does that look like? Correct.
It would be, it would be down one.
And it's a parabola shooting up, right?
Yeah.
That's really ugly, but anyway, okay. Is that one?
No.
No, okay. So what's gonna happen on that, if they're saying, I want you to find the inverse, they're gonna say this, x is greater than or equal to 0. Okay, so really we're just talking about, not this part, but that half. Okay, so that's x squared minus 1 when x is only greater than or equal to 1 half. Okay, so they're eliminating the double values and they're making it 1-to-1. Okay, so this is now a 1-to-1 function. Okay, because I've eliminated the double values. All right, so now we can find the inverse. All right, so how do we find the inverse? First step, Riley? All right, so that looks like x equals y squared minus 1. Okay, you don't have to worry about the domain. All right, we're still going to do the same thing. I'm not sure why I wrote that so weirdly. Let's try that again. Okay, then what am I going to do to solve it? It's like, okay, and lastly, I'm going to take the square root. Now, when I take the square roots, how many values do I have? I have a plus and a minus. So we got to decide which one according to this one. Because we're not going to take them because that requires 2 values. That's not even what we want. We want a 1-to-1 function. Okay, which one are we going to grab? Positive. Okay.
Can you put something in absolute value? So that it comes out positive?
So you have a square root of an absolute value of the square root?
No.
Kind of complex.
Absolute value one.
So you're having the absolute value of the square root. No, that's just remove the negative, you're good.
Okay. So we should add a positive to the outside or just
No, just leave it, leave the plus and minus off.
Okay.
Because if we had, let's say we decided to do this, okay, which is this piece, okay? So now we, the inverse, just make sure this, we know that's what that is. The inverse this time is going to be what? Same thing. But now we're going to grab the negative piece because those are the numbers that we have. Those are the only numbers that we're considering, so those are the only numbers that we're going to get. Okay? We're not going to get crazy over that, but I'm just saying sometimes you might see something like this on a standardized test. You're like, what does that even mean? You're just trying to make it 1-to-1 function. You're just saying x is only now greater than 0, so only talking about those values. Okay? I think I'm done. I don't know what else I need to do. Let's see. Okay, we got a quiz real quick here.